Section 5.4, Factoring Quadratic Expressions, continued. Recall from previous sections that when we factor quadratics, we're going to rewrite the expression as the product of its factors. In previous sections, we've looked at factoring G.C.F. and factoring in the form of x squared plus bx plus c, where c is greater than 0 and c is less than 0. Here, we have a very similar form. Here is an ax squared plus bx plus c. C can be less than or greater than 0. B is still the coefficient of x. And now what we're going to do is have an a coefficient in front of our first term for the x squared. Usually this has been a positive 1. Now a can equal any real number. That can add a little bit more difficulty in the form of factoring. My first example in factoring the form of ax squared plus bx plus c. Here, a is represented with a 2, b a negative 3, and c a negative 5. I want to begin, as we have in the past, by setting up two sets of parentheses to represent the product of its factors. I want to break up the first term. I want to break up 2 into its factors. Here I know it's 2 times 1. Therefore, I know x is going to be in both factors. So 2 and 1, 2x times 1x gives me 2x squared. Now I need to break up my c, which is going to be 5 times 1, or 1 times 5. For the first term, I leave it in 2 times 1 or 1 times 2 the way I start with. I don't need to keep switching them because I'll switch the backed 2 factors. So let's test. I will plug in a 5 and a 1. And if I recall, since c is a minus sign, I'm going to have a plus minus or a minus plus. And these 2 factors was multiply to give me 5, but also subtract to give me my middle term, which is here a negative 3. So if I do my outer and inner terms, I'm going to get 2x times 1, which is going to give me 2x. 5 times x is going to give me 5x. And 5x minus 2x gives me 3x. Now all I need to do is to set up my signs. Since I need a negative 3, my 5 will be negative, and my 1 will be positive. And I can verify by using the FOIL. First, 2x times x is 2x squared. Outer is 2x. Inner minus 5x gives me a negative 3x. And my last is going to be a negative 5. Therefore, the product of factors is the quantity of 2x minus 5 times the quantity of x plus 1. On the second example, we're given the form of ax squared plus bx plus c. I want to generate a set of parentheses. That gives me my product of factors. X squared will break up into x and x. 6 will break up into either 6 times 1, or I could put 1 times 6, or 3 times 2. I'm going to choose 3 and 2. This is just a guess. And what we do is we're just going to plug in our values and check. Now I know that my first term is going to generate 3x times 2x gives me 6x squared. Now I'm going to try my last term, which is where I'm really concerned with the order of my factors, which would be 3 times 1 or 1 times 3. Again, from previous sections, I know that I'm going to add my outer and inner terms to get my middle term. So let's try our 3 times 1. 3 times 1, I know my last term is going to get 3. My inner and outer term is going to be 6x and 3x. 6x plus 3x is not going to generate my 19. So therefore, I'm going to erase the 3 and 1, and I'll try the other order, which will be 1 and 3. Again, my first and last term are going to work out. My inner term is going to give me 2x. My outer term is going to give me 9x. 9x plus 2x is going to give me 11x. That doesn't work. Now that tells me, since I've tried my 3 and 2, and 3 and 1 and 1 and 3, that it didn't work. I have to now change to a 6 and 1. So I'll erase each of these numbers. And I'll replace my first set with 6 and 1. That gives me 6 times 1, which is 6x squared. Now what I'll do is I'll try my 1 and 3 again. 1 and 3. My inner term is 1x. My outer term is 18x. 1x plus 18x gives me 19x. Now I just need to determine, is this minus minus? That would generate my positive 3, but that would give me a negative 19x for my middle term, and I need a positive 19x. So that means this is going to be plus and plus. And when I check my FOIL, my first 6x times x is 6x squared. Outer, 18x. Inner, 1x. Gives me my 19x. And my last is 1 times 3, which is 3. Let's look at another example. Here I have 6x squared minus x minus 12. That gives me my form of ax squared plus bx plus c. I'm going to generate my two sets of parentheses. I know that x will break up into x times x. And then I need to get a 6. That's either going to be a 3 times 2 or a 6 times 1. Let's take a guess by starting with 3 times 2. And now I know 12 has several different sets of factors. That could be 3 times 4, and of course 4 times 3, 6 times 2, and of course 2 times 6, and 12 times 1, or 1 times 12. And hopefully we hit on the first lucky one so we don't have to keep going through set after set after set. Let's take a guess and go with 3 and 4. I know from my original expression that I need to subtract my outer and inner terms to get my middle term. And I know it's going to have to be a plus minus or minus plus to get a negative 12. We know from doing our first, that will give me 6x squared. And doing the last will give me my 12, just depending on plus or minus. Now let's look at our outer and inner terms. Our inner term is 6x. Our outer term is 12x. 12x minus 6x gives me 6x. Therefore, I know 3 and 4 won't work. So I go back to the drawing board. I erase those two factors, 3 and 4. I leave 3 and 2 until I go through each set of factors and also flip each set of factors. And if that doesn't work, then I go back to 6 and 1 and try each one again and flipping each one. So we did the 3 and the 4. It didn't work, so let's try the 4 and the 3. And again, my first and last terms still generate my 6x squared and 12. My outer is going to give me 9x. My inner is going to give me 8x. 9x minus 8x, because I have to subtract. 9x minus 8x gives me 1x. So this is going to work. Now I just have to determine where my plus and minus signs go. Since I need a minus x, this is going to give me a positive 4 and a negative 3. And how do I know that? Because when I do my outer, that gives me a negative 9x, and my inner will give me a positive 8x. A negative 9 plus 8 gives me a negative 1. And I already verified that my first and last work out. Our next example, I'm given the form of ax squared plus bx plus c. Let's break up our first term. I know that's going to be x and x. I know that the 4 will break up into either 4 times 1 or 2 times 2. I'm going to try 4 and 1 because I need a big number in the middle. After a while, you'll get used to seeing how things work out. But still, plug and check is the way to do it. So I have, for my first term, 4x times x, which gives me 4x squared. My last term is either going to be 15 and 1, or 1 and 15, or 5 times 3, or 3 times 5. I'm going to check by putting in a 15 and a 1. So my first term is 4x squared. My last term is 15. So this works out. Now, I need to determine my middle term. Recall I need to subtract my outer and inner to get my middle term. And when I do that, my outer term is going to give me 4x. My inner term is 15x. 15 minus 4 is going to give me 11x. I need 59. So 15 and 1 doesn't work. So I'll erase 15 and 1. I will try 1 and 15. If 1 and 15 doesn't work, then I'll go back and do 5 and 3, or 3 and 5. If those don't work out, I'll plug back in 2 and 2 and go through the same order. So 15 and 1 didn't work, so I'm going to try 1 times 15. Again, my first term is 4x squared. That works. My last term is going to generate a 15. That works. My outer term is 4 times 15, which is 60x. 60x minus 1x is 59x. Now I just need to determine my plus and minus. And to do that, I need my bigger number to turn out to be positive because my middle term is positive. So this is going to be a minus and a plus. So looking at my FOIL, 4x times x is 4x squared. My last is going to give me my negative 15, and my outer, 60x minus 1x, gives me a positive 59. Therefore, the product of factors is 4x minus 1 times the quantity of x plus 15. On next example, again, we have the form of ax squared plus bx plus c. I need to generate two sets of parentheses. We know that x squared is going to break up into x and x. And now that I see I have perfect squares on my front end and back end, or my a term and my c, that I'm going to try perfect squares first. Therefore, I know that 4 breaks up into 2 times 2 and 4 times 1. And I know 9 breaks up into 3 times 3, or 9 times 1, or 1 times 9. But when I see perfect squares in the front end and back end, or the a term and a c term, I'm going to try those first. So 2 times 2, my first term, 2x times 2x is 4x squared. And my last term, 3 times 3, gives me my 9. Now I'll try my outer and inner. Knowing from the addition sign in front of my c, I need to add my outer and inner to generate my middle term b. Gives me 6x plus 6x, which gives me 12x. Now with the plus 9, it's either going to be minus, minus, which would give me a negative 12x, but I need a positive 12x, so that's going to be plus, plus. And when I check my FOIL, first gives me 4x squared, outer and inner gives me 12x, and my last gives me 9. That generates a perfect square trinomial, so I'm just going to put this as a set of binomials squared. So that's 2x plus 3, quantity squared. My next example, again, ax squared plus bx plus c. Again, I see that I have perfect squares in my a and c terms. So I'll put up a set of parentheses. X breaks up into x and x. And I'm going to try the perfect squares. Again, we know that this is 3 times 3, 4, 9. And if not, I have to use 9 times 1. And for the 16 is going to be 1 times 16, or 16 times 1, 2 times 8, or 8 times 2, and of course 4 times 4. And when we see A and C being perfect squares, I'm going to try the perfect squares first. 3 and 3. My first term generates the 9x squared. My last term is 4 and 4, which generates my 16. Again, I need to add to get my middle term because of the plus sign in front of my c. 12x for the inner term, 12x for the outer term. 12x plus 12x is 24x. Now I just determine whether it's plus, plus, or minus, minus. Since my b is negative, it's minus, minus. And then I see that each expression is the same. So I write it as a square binomial, 3x minus 4, quantity squared. Therefore, these are perfect squared trinomials. On this slide, we'll define a new method of factoring. This is called difference of two squares. When given an expression in the form of a squared minus b squared, in other words, I have a binomial, 2 terms. The first term is a perfect square represented by a squared. The second term is a perfect square represented by b squared. And this must be a minus sign, which is the difference of two squares. It cannot be a plus sign. Then it can be factored in the form of the product of its factors. In other words, we put down two sets of parentheses, as demonstrated here, and I break up the first term by its perfect square, a and a. The second term breaks up into its perfect square, b and b. And here I have a plus minus sign. Either we have a plus minus sign or a minus plus sign. In other words, the signs just have to be different. And the reason that is the case is because that will eliminate my middle term. Notice, if I have a middle term, that will give me a trinomial, as I had in the previous sections for the product of its factors being two sets of parentheses. So let's verify that to see why that middle term drops out. So if I FOIL, a times a is a squared. My outer, negative b times a is a minus ab. My inner term, positive a, positive b, gives me a positive ab. And my last term, positive b times a negative b, is a negative b squared. And notice, when the signs are different, here plus minus, and the coefficients in my expressions are the same, here 1ab and 1ab, then what happens is my middle term drops out, leaving me my perfect squares, which verifies the difference of squares. A quick example would be if I gave 4y squared minus 1. Here, I know this is not a trinomial. Usually we'd have 4y squared, a middle term with a y in it, and then the constant. But here we're just given my ax squared minus c, or plus c. And when I see this is a perfect square and this is a perfect square, then I put down two sets of parentheses. The perfect square is 2y and 2y. And if I FOILed, 2y times 2y is 4y squared. 1 is a perfect square, 1 and 1. And I know my signs are plus, minus. I can check that in my head by 2y times 2y is 4y squared. Positive 2y, negative 2y, that will drop out when I add them together, leaving me with a minus 1. Let's take a look at some examples. Here I have y squared minus 25. Y is a perfect square, 25 is a perfect squared, and I have a minus sign. That is a difference of two squares. When that's the case, I have two sets of parentheses for the product of factors. Perfect square of y squared is y and y. 25 would break up into 5 and 5. And that leaves me symbols of plus and minus. A quick FOIL, y times y is y squared. Positive 5y minus 5y. That middle terms drop out, and that leaves me with a negative 25 for my last term. Next, 9z squared minus 16. 9z squared is a perfect square. 16 is a perfect square. I have a minus sign. Therefore, that is a difference of two squares. Put down two sets of parentheses. 3z squared breaks up into 3z, 3z, 16 into 4 and 4. And I have my signs of plus, minus. Quick verification. FOIL, 3z times 3z is 9z squared, minus 12z plus 12z. The middle term drops out, and my last term, minus 16. Our next method of factoring is to factor completely. In other words, we want to combine all of our methods of factoring a G.C.F., factoring a trinomial, factoring perfect trinomials, and factoring difference of squares. So the rule of thumb is to, one, we want to check through the expression and see if I can factor out a G.C.F. If I can, then I must do so. After that, I will factor the trinomial, whether it's a perfect trinomial or any other trinomial, and then I will factor difference of squares. Two more quick examples here. Again, difference of two squares, 81k squared minus 1, both perfect squares. Therefore, the product of two factors, I set up two sets of parentheses. 81k squared breaks up into 9k, 9k. 1, of course, is a perfect square. That's 1 and 1. And my symbols are plus, minus. Here, m squared minus 1. Again, difference of two squares. two sets of parentheses. For the product of factors, m squared breaks up into m times m. 1, again, perfect square, 1 and 1. Symbols plus, minus. Let's work some examples to factor completely. Here I have a binomial, 8m squared minus 8. First rule is to factor a G.C.F. Here I can factor an 8 out of my binomial. 8m squared divided by 8 leaves me m squared. Bring down the minus sign. 8 divided by 8 leaves me 1. I look inside my set of parentheses and I realize this is a difference of squares. So I always bring down the G.C.F. because each level has to equal what I started with. Then I put down two sets of parentheses to factor my difference of squares. M squared breaks up to m times m. 1 is 1 and 1. And my signs are plus, minus. And I know each level equals the original expression. Next, I have a trinomial. Here I realize I can factor out a 3. When I do, 3x squared divided by 3 is x squared. Negative 6 divided by 3 is a negative 2x. Negative 24 divided by 3 is a negative 8. Now I factor my trinomial. Put down a set of parentheses for the product of two factors. I know x breaks into x and x. 8 is either going to be 8 and 1 or 1 and 8. 4 and 2 or 2 and 4. And realize that this is a minus sign, so my signs are going to be plus, minus, or minus, plus. And my factors must multiply to give me 8, but subtract to give me 2. Here, I'll use 4 and 2, because I do know that 4 minus 2 gives me 2. And I know that 4 is going to be the minus because it's a middle term that's negative, and my 2 will be a plus. And when I FOIL, that's going to give me x squared minus 4x plus 2x, which gives me a minus 2x, minus 8. Next example, 3r squared minus 27. Again, I'll factor out a G.C.F. Here it's 3. Leaves me an r squared minus 9. That's a difference of squares, which is going to give me two sets of parentheses. R squared breaks into r and r. 9, 3, and 3. And my signs are plus, minus. Next example, 2x squared plus 6x minus 20. Factor a G.C.F., which is 2. 2x squared divided by 2 is going to give me x squared. 6x squared divided by 2 is 3x squared. Negative 20 divided by 2 is a minus 10. I have a trinomial I can factor. X squared factors into x and x. 10, the factors are 10 times 1 is 10. But when I subtract, only gives me 9. I need a 3. Notice I subtract because the minus sign in the last term. Next would be 2 times 5. 2 times 5 is 10. 2 from 5 leaves me 3. So my factors are going to be 2 and 5. My middle term is positive, so my number by the 5 will be a plus. The 2 will be a minus. When I FOIL, that gives me x squared. Negative 2x plus 5x is 3x, minus 10. My last two examples. Recall when given a trinomial or binomial, I like my first term to be positive, so I need to factor out a G.C.F. that's going to be negative. Here, I have a negative 4 that I can factor. Negative divided by a negative is a positive x squared. Negative divided by a negative is a positive x. And a positive divided by a negative is a negative 6. Now I can factor the trinomial. X squared can factor x and x. 6 is 6 and 1, or 3 and 2. And here, it needs to subtract to give me my middle term, and multiply to give me 6. That will leave me 3 times 2. My sign will be plus, minus, and I can FOIL to verify the product of factors for x squared plus x minus 6. Also recall that each of these equal the level above, and also the original. Last one. Again, my first term is negative. I need to factor a negative out, and any other G.C.F., and here it will be 10. When I do that, that will give me a negative 10 divided by a negative 10 is a positive 1m squared. Negative 40 divided by negative 10 is a positive 4m. Positive 210 divided by a negative 10 is going to give me a negative 21. Negative 10. Factoring two sets of parentheses for the trinomial. M squared is m and m. 21 is 21 times 1. And I need to subtract to get my middle term. That will give me 21, but not 4. The other one will be 7 times 3. That gives me 21. And when I subtract, it gives me 4. So my factors are 7 and 3. Here, since this is a positive 4, my 7 will be positive, my 3 will be negative. And when I FOIL, that will verify each step.